Have you ever wondered what it's really like to be a student today, trying to get your head around a huge subject like calculus? It's definitely not just about getting a heavy textbook and locking yourself in the library anymore. So let's pull back the curtain and take a look at the entire system, the whole ecosystem that makes up the modern calculus classroom. So that brings us to the big question, right? What does it actually take to learn calculus in this day and age? The answer might surprise you, because both the tools and the way we think about learning have evolved in some really fascinating ways. And here's the key thing to get. It's not about a single book, not at all. It's a whole ecosystem. You've got physical texts, you've got digital platforms, different teaching strategies, and even completely different business models, all kind of swirling together to help a student learn. All right, so our journey begins where every student does, that first day of class. You get your syllabus, you find out which textbook you need, and you get that first kind of terrifying look at the mountain you're about to climb. For the student in our story, this is the home base, the first edition of Calculus from OpenStax. It's an open source book, which is cool, and it's designed for a pretty standard 2 or 3 semester course. The whole goal is to make the core ideas of calculus accessible. This is square one. And here's that mountain. Whoa, just look at this syllabus. It starts with functions and graphs, then limits, derivatives, integration, and it just keeps going all the way to differential equations. We're talking about a staggering 17 chapters in total. All of a sudden, you can see why just one textbook might not be enough to get you through all this. So how in the world do you tackle a 17-chapter beast like that? Well, you turn to the Digital Toolkit. For a ton of students, that means using a platform like WebAssign, which works with textbook publishers to bring all this material online and make it way more interactive. First tool in the box, the ebook. Now, this isn't just some flat PDF of the book you can buy in the store. The whole point here is interactivity. The text is packed with features you can't get on paper, like being able to click directly from a tough homework question right back to the exact section in the book you need to review. Super handy. Then you've got course packs. You can think of these as pre-built homework assignments, all put together by experts who know this textbook inside and out. It saves instructors a ton of time, and for students, it gives you a really structured way to work through all that material. Okay, now this is where things get really interesting, because you can see how the digital toolkit changes depending on the book. On the left, you've got the open source OpenStax book. The ebook is just included. Its killer features are things like these amazing interactive 3D graphs and helpful tutorial questions. But then on the right, you have a traditional publisher like Cengage. You might have to pay extra for their ebook, but they offer different tools, like watch-it videos that literally walk you through a problem, or a personal study plan that adapts to how you're doing. There's no single right way. It's a whole ecosystem of different approaches. But we've all been there, right? Even with the best digital tools in the world, there's always that moment where you just get stuck. You hit a wall. And this is where modern teaching has to go beyond just formulas and into the world of thinking strategies. So yeah, what happens when those interactive graphs and step-by-step videos just aren't cutting it? What do you do when you're just staring at a word problem and you have absolutely no idea where to even start? This is where the focus shifts to something called math reasoning. And the whole idea here is to build the skill of making sense of the math itself. It's about understanding the why behind the problem, not just, mechanically solving for X. It's about seeing the logic, not just the numbers.
So how do you actually build that kind of reasoning? Well, here's one really cool concrete strategy. It's called cubes. You circle the key numbers, you underline the actual question, you box the math action words, you evaluate the steps you need to take, and then finally, you solve and check. See, this isn't about memorizing formulas. It's a process you can use to break down any problem and make it feel manageable. Okay, so let's zoom all the way out one last time. All of these textbooks, these digital tools, these thinking strategies, they all exist inside a much bigger picture, the business of education itself. And in that world, you've got different models competing to shape the future of learning. So you've basically got these two big models, right? On one side, you have the OpenStax model, a nonprofit built on open source ideas, trying to give away materials for free or for a very low cost. And on the other side, you've got the huge publishers like Cengage, who have been creating and selling these really comprehensive course materials for decades. Both of them work with platforms like WebAssign, but their core philosophies and their price tags are worlds apart. And this tension isn't just theoretical. You see it playing out in the real world all the time. I mean, just look at this post from a subreddit for math teachers. It cuts right to the chase, doesn't it?
It just shows you that there's this constant search for free alternatives, which tells you that cost is a huge factor in this ecosystem for everyone, from students to entire schools. So after looking at the textbooks, the digital tools, the mental tricks, and even the business models, it all kind of leads to one big final question. What's the actual goal of all this? At the end of the day, what are we really solving for? And I think this quote from our source material on math reasoning really just nails the answer. The ultimate goal isn't just to get students to pass a test. It's to build their belief that they are capable of doing math. And, this is the big one, that mathematics actually makes sense. It's about building real confidence and genuine understanding. Which leaves us with this one last thing to think about. In the modern calculus classroom, with this whole ecosystem of support, what's the real final exam? Is it just about cranking out the right answer? Or is it about developing the reasoning and the confidence to truly understand the question in the first place? Definitely something to chew on.